Oh, has the stream been down the whole time? Oh well, whatever. I had it on for like an hour and a half. I guess OBS crashed and I didn't come over here to look at it. Oh well. I made a new, or the encoder holder part. Anyway, I reprinted a encoder wheel because the other one peeled off the bed. Yeah, well, I had it on for a while now, but apparently it did not work. It's alright. Whoops. Just pulled the mirror off. Oh well. Yeah, this one, see how it warped? And it closed the holes on this one section right here. That's okay. I printed another one last night. Now I'm gonna print the other part. Hopefully this thing will print better. The tuning apparently did not work very well. I think it needs to go down a little bit. That looks pretty good. Okay, so I need to test a few things. I can test the encoder wheel temporarily by holding it. Peeling off the bed. Good morning, Ike. Okay. So my place is a disaster. I'm going to clean off the books that I got from my best friend. One of them. Set them right here. And keep reading them. I read a few bits and pieces here and there. There's lots of good things. Okay, my place is a disaster. I think I know what I'm doing now. I think I know what sensors I'm going to use so I can design the opto isolator portion of this. the circuit can be designed. The board could be cut. Shielding could be made. I got lots of stuff to do. Maybe by the end of the week I'll have something working. Hopefully before that, to be honest, but I can only do what I can do. I would really like to put this on the wall, but I really don't want to screw holes in the wall. Yeah, maybe I can just hang it on here. That's fine for now. Alright, so this key sensor, I actually have the manual for this particular one. I want to hook it up to the Arduino. I want to put the extensions on there. I'll find the English version. Oh yeah, see, that looks a lot better. I wonder if I should have printed. I used the wrong slicer settings for my other doodly dab. So you know what? This big I think I'm going to just put this right here. Put that in the corner like that. Put you back over here on this one. Fix this. You're fixed there. Just put this down in the corner. And then apparently clear my throat. You guys should be able to see everything. There's like every language I've seen on this paper. Okay. So this sensor is being powered by 24 volt. Huh. I did not know transmitter receiver are different. This says it has a single core and multi-core. Can't tell, but okay. So wiring scheme is as stated. High speed mode. We like high speed mode. You know what? How many of these do I have? I don't have a... Yeah, maybe I could use... Oh, it doesn't matter. That's the easy part. I don't want to put these on the receiving side. Okay. Where be's the schematic, yo? For outputs. You see nothing? Say nothing about color code. Oh, it's on the side. It's funny. Brown is positive. Black is out, blue is ground. So I'm going to use the other side of the supply. So I got ground. Ground is blue. Positive. I mean black is black is output. Blue is ground. And brown is positive. We have power! Okay, and then we're going to put a fibri in there. Why is it so bad? Uh-oh. There's a granule in there. Ha! No wonder the thing got replaced. That's pretty funny. There's crap in there. I'm going to take it apart, I guess. That's funny. Now we know why it got replaced. If I can pop the whole thing off and have me a look. Don't think they're glued together. They look like they should come apart. That's pretty funny. Always gotta figure out why things happen. Now we know. This one had a granule stuck inside the laser module. Problem right now is I cannot seem to get this pot. I do not want to break it. I'll do what I have to though. Maybe start from this side. Seriously looks like it just snaps apart, but surely there'd be like, well, I would guess there'd be a screw somewhere in here. Well, I do not see one. I think for being an industrial sensor it'd be a little bit more robust, but apparently not. Okay, well, if I can't get it apart, I can get that thing out of there some way or another. I would like to just, there we go, pop this thing apart. Yeah, there we go. Oh, it's nice and shielded. It's cool. Wow. It's very nicely shielded. See if I can get you a better shot of that. It's got a copper sheath around the whole circuit board. Now let's get into this laser module. Aha! Alright, there we go. Well, that's good to know that this module's shielded pretty good. Alright, now we should be good. I guess I'll power it back up before I put it back together. Power is brown. Shield. I mean, blue is ground. Oh yeah, much better. Much better. Okay. That's cool. That's cool. Glad I fixed it. The other one should be fine. This one apparently got replaced because it was faulty. Whoops. Alright, so I got mode. Okay, and then my output I'm going to connect to the scope for a second. Go to the green channel. Green channel, please. Thank you. So we're going to go from the output to green. Looks like it's pulsing really nicely. Those rise fall edges are nice. Okay, so I can change the thresholds on this sucker too, but let's try this. I'm gonna attach. I'm gonna go ahead and make up my extension actually, so I can check the whole thing works. So we got this piece and this piece. These are gonna be my two extensions. They're both pretty good. This one looks a little worse than that one. And my little black attachment modules here. And this goes in that side and this gets threaded into this side. Okay, this one, just going to shove in this hole, and that's basically the whole thing. And then this guy, not this end, this guy. That's enough light shining through there. So I don't know which side this one is, but it's fine. This one side has the solid. That's pretty bright. Let's see if we can register. Oh yeah. Tick 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 tick. Man, this thing has to be pretty fast, so we might have to adjust some things, but in general, let's give this a whirl. Oh yeah, look at that. So we got, see if we can find our index pulse. Pulse, 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 and our index. It's right there. See the longer pulse. And the same thing over here. Our index is right there. Cool. If I wanted to try the slower one, okay, same thing with the doodly dads. So we got our index pulse there, I can see it. Dun 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 dun. Alright, so there's my encoder pulse. These should be the same timing on all times. From leading edge to leading edge. Alright. Now that part's printing pretty fast. One corner's peeling off the bed though, but that's fine. See, I'm gonna start up this. And I need to pause this. Good day, sir.
Hey, how you doing?
Richard, we're live. Join the fun.
Okay, cool.
So you can see my screen at the moment.
Yep.
All right. So right now I was just checking the pulses to see how close they were. Should be pretty much perfect, but I didn't clean up any of the plastic on the encoder wheel, which means there's some bigger and smaller, and that could cause us problems. But
That's nice.
yeah. So
I see the index pulse.
that's the index pulse. I was gonna measure, you know, a few things here and make sure. Let's see, falling edge. And it's rising edge, about the same. So you know, this is the smaller. Hi, honey. This is the smaller one. Not the smallest, the medium one, and this is about 31 milliseconds. So I was thinking, in your program, if you if you checked for rising and falling, then you could just, every time it comes back, you could run it against a check and say, is it bigger than
so many milliseconds? Yeah.
Well, that, or you'd have to check it against the rest of them, or one of the other ones. And I say that because the speed changes the timing.
Oh yeah, right. Okay.
So you have to do something like that where you're constantly looking for it. You could even look for it every, I don't know, couple of seconds or something, right? You don't need to do it every time unless it gets out of whack. You could just like follow up on it, do like a check or something. I don't know. You do whatever you want. I'm just showing you what I got. So
yeah, I know. Awesome.
So this is the oscilloscope. Right now these pulses are, it's on the 20 volt scale, so it's a full. Is it a full pulse? Let's see.
How many pulses per rev we got right now?
So
45.
That's 12 volt. So I got 60, 30, and 12, and so this one is the 30.
This is 30. Okay.
So let me show you here. Let me run this thing. I'm gonna get a big window so I can get a good shot of it.
All right. You got you know what RPM you're running it at, or?
No, we can figure it out.
Okay.
Hold on, I'm just gonna spin this thing up and see if I can get any good action going on.
All right.
Okay, that's pretty fast. So let's go see what we can see. Looks like a mess.
Looks like a mess.
It's there though.
Yeah, it's there.
So like
that scope is so sweet, man.
What's only at, oh, it's on 1 million. Yeah, it is awesome. So so here
11, I want one too. Not really. I'm just joking.
Okay, so total time, that's 435 milliseconds between index pulses.
Okay, let me figure out what RPM that is here.
And then I can check the width of 1 and tell you how fast you need to figure it out.
So that's 137 RPM.
Okay, so that's only 137. Okay, and each pulse width is about 2.4 milliseconds. So
2.4.
Yeah.
And the index is about 5 then, or what?
Oh, let me check. Yeah, see, I think we're gonna have to go to the lower one, because that's already cutting it pretty fast, and we're only at 100 and something RPM. You double that, and everything doubles. It might not even. This signal looks like it's falling kind of slow. I think I can adjust all that. It's about 4.6.
Okay.
But see how the beginning and end.
You could always make that an index pulse that was triple wide instead of only double wide.
Yeah, but then I thought it would be easier in your math that you never ever have to check. If you check the rising and falling, okay, then you never have to check the index pulse if you don't want to. Well, what I mean by that is I gave it exactly the same amount of pulses. And there's no skips.
Yeah, no
I just made one bigger. That way, if you're checking the front edge, you don't have to worry about that. I kind of made it hopefully easier that way for you.
Yeah, as long as I start with a rising edge. If I happen to start with a falling edge, then I'd be measuring the gaps instead of the pulses.
Right, so you have to measure the rising edges to make it timing. So look, this is...
But if I go from rising to rising, then I got a better chance at it, because if I go from rising to rising, like move your cursor over there, what does it measure out on the index pulse right there?
The bottom?
From rising to rising, it should be like 8 milliseconds or something, right? Going wrong way. Oh yeah, you can go that way. No. Yeah, there you go.
9.7. So you're saying,
Yeah.
oh, so you want to go rising, 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 rising. Then you'll still get.
It. And I don't ever get out of sync that way.
Hold on. Let me check something.
All right.
If I go from rising to rising here.
Should be only about 6 or 5.
Okay. 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 So you could go. Yeah, you could use exactly. Wait, how does that work?
Don't worry about an odd number or an even number. You can put as many gaps in there as you want. You can put a three wide gap or anything, and I just go from rising to rising.
Well, again,
I mean, if we get going fast and we find out that our index pulse is just too hard to detect, we could just make the index pulse a little bit bigger.
yeah. So, like for instance, let me think about this. Rising, rising, rising. Pretzels. Dang.
I'll do it however you want. If you don't want me to do it that way, that's fine.
Can you carry the laundry basket upstairs?
What? Hold on, Richard. What?
When you carry the laundry basket upstairs.
You need it right this second?
No, just sometime.
Okay. At lunch?
Put it away.
Sure, I can do that. I can do that. Thanks, son. I designed this in my head thinking it would be helpful. Let me think about this with you for 1 second here.
Okay.
So my encoder, I made one of these I made so it wouldn't change, and one of these made so it changed. So what I did is I moved everything that way. Oh, you know what? It might be inverted on there. That's why I'm confused. See, so let's see, on. Technically, when it turns on, everything should always be the same.
Oh.
And it should never change. So it just could be the fact that I got this inverted, and I'm thinking upside down.
Go from the offs and see if that works out then.
So if the offs.
From the falling edge to the falling edge.
So from the falling edge to the falling edge is the same there. It's the same. It's okay. Fair enough. It's the same there, and it's the same. It's the same there. So I wonder. Okay, so the
I can't detect it on the falling edges then because of the way you designed the thing.
Right, and I did it on purpose. So you could use one side of it as a constant, non-interrupted encoder.
Yeah.
And then you can detect a different way, or you can do something you want, however you want to do it.
Yeah, but I can't have one signal going into 2 different interrupt routines, I don't think. Yeah, I see exactly what you did, and I understand it.
Okay. And I did that on all of them. I did that cool. even on the really, really big one. So like, look how big the big one really is. It's really big. The 12 count.
Yeah.
I'm gonna zoom in. So 12 count. Get this thing going. And once I get this set up, it'll be a lot more precise.
Yeah.
But
I don't know how fast this little rinky-dinky microprocessor is going to be able to go, so we may not be able to do the 60, but we'll see.
Yeah, so see how much bigger of a pulse that is?
Yeah.
Because this is about the same RPM. Well, actually, let's just verify that. See what we're really at here. Over here should be...
This is 12?
Yeah. I mean, maybe I'm wrong, but it seems like it'd be plenty fast. So that's 497 milliseconds. That's for the whole thing, or is it? Yeah, it was. And
That's
then
120 RPM. Yeah, it's about a little slower, but.
And then and so, and you know, if I start going too fast, this sensor, it does have a high speed mode. This one's different than the other one, and it should be a lot faster. It doesn't have that. I don't think this one has that delay.
Well, I'm not really worried about the speed of your opto at the moment. I'm worried about the speed of my microprocessor.
I know. So, right, so here, the falling edge is not synced. Okay, as long as you see what I did,
Yeah,
then,
I see what you did.
then you're golden. You can do it however you wish to do it. It seems like we should start at 12 pulses.
Whatever you want to do, I don't care. I mean, the software should work no matter how many pulses you have.
Well, the slower it is, the more chance we can make sure that.
Well, actually, yeah, I do have to know the number of pulses because
You got to calculate that, yeah.
I calculate degrees if I don't know how many pulses I'm getting. Well, I could actually count the pulses if I can detect the index pulse.
Right, yeah. Yeah, then, well, yeah, then you'd have a check routine or something to make sure it's always right or something, but.
So, like on the 12, even though there's an index pulse, it's still one of the 12, right?
That's correct. So you can always detect an edge.
Like, man, you're so smart. I can't believe it.
I am thinking ahead, sir. Now it's up to you to make sure it works.
Oh, no pressure there.
Yeah, exactly. None whatsoever.
Sweet.
So I got yeah, this should work. This sensor's awesome. I can set this right now. The sensitivity is super high, so I think if I set it a lot lower, I'll get a cleaner pulse. Right now, that falling edge it falls because this thing is like super sensitive.
I gotta make sure I don't get double triggers, but I might be able to do some filtering in software.
So so again, we can just change the amount of pulses and do whatever we want. If you would like to start with 12, that's cool. If you want to start with 30, that's cool. It's got a little bit bigger index pulse than the 60. It's the same width pretty well, but it's got a little bit longer index. I mean, technically I could cut this or drill holes like you said, and I could make the pulses a lot shorter, and then I could make the index a lot longer and keep the same architecture of having this constant leading edge always the same or whatever. Anyway, well, as long as you know what we got.
So are you going to leave it that way, or are you going to invert it? Because you said you.
I can do whatever.
Well, I just need to know which way it's going to be.
Well, right now it's. What is it? Right now it's off.
It's constant.
It's up when it pulses, and it's off for most of the time. So that means the gaps. It's on. Yeah. So right now the trigger. Right now, when the light passes through it, it gets a pulse output.
Okay, and that's what changes. The falling edges are all equal.
Let's see. In this case. Yeah. The falling edges are all equal.
Right, and the rising edges are different.
Let me verify that. Falling edge, and falling edge. That's correct. So right now all our falling edges are equal. Now here's the problem with that. The falling edges are kind of lagging here. See that decay time? Now I can probably change that in this controller. You can do a bunch of really fancy stuff with it. It might not even be on high speed mode for all I know.
Well, I can.
So I got 1,000 things to change. I just wanted to see if it would work first.
Yeah, it's working awesome. That's great.
And I'm printing off the thing. So here you go. 250 microseconds is fine. Turbo, super turbo, ultra turbo, high resolution is 50 microseconds. Is high speed. So I can, yeah, 50 microseconds is as fast as I can get in and out of this controller, basically. So we just need to make sure we don't get close to that, and we'll be fine. I say
20. That's 20 kilohertz.
Oh yeah, there's
20 kilohertz.
Okay, so that would be
that's super max, but most okay. So.
And that's if everything's like super awesome and amazing, and honestly, everything should be fine. But I'm splicing cables together to make sure I get a good clean distance. So what I'm saying is my integrity of light slightly diminishes, but it should be fine. It's reading really well, so I'm sure it's fine.
Yeah, I don't think we'll be able to go that fast.
No, your side probably won't even work that fast.
No, the computer, but I mean, I don't think the wheel could even turn that fast to give a 20 kilohertz pulse rate out.
Alright, well, I'm going to...
It'll be over 650 RPM.
I think I'm going to splice together as many cables as I have. And, I got
I'm gonna go think on the code here and try to see what I can work out.
Alright.
I'm gonna do the interrupt routine first and try to get the counts, and then figure out how to give myself a degree pulse internally in software, so I know what degree position I'm in. Then you can dial in degrees on your display.
Yep, exactly. That would be helpful. Also, we need, before you get too far into this, we need to rethink. Well, we need to rethink everything. What I mean by that is, we just need to think about this for a second. So, we probably should write all this down again and restart our document a little better. So, what I want to be able to do, what I want to have the option to do, right?
Yeah.
And this may not apply to running. I don't know yet. But what I want to do is I want to be able to set the timing in such a way where I want to try to understand, let's say the resonant frequency is 110 hertz.
Right.
So I want to hit, let's say, a quarter wave of that. So when I turn it off, I want to be able to turn it back on or short it at a quarter wave resonant peak, okay?
Yeah.
Which means I'll catch it at a certain spot. So let's say that's the scenario I want. I want that to stay fixed, independent of RPM. So there's a couple of things here that are gonna get. We just need to sit down and make sure we are both understand exactly what we're trying to do, because like the shorting side of the thing right now is included in the degrees, right?
Right.
But really, I'd like to have the ability to change that. So however you write your code, you should write it in a way that makes sense for that. Because if I don't tell you that ahead of time, then you might have to redo something that's going to be tedious, and that ain't no fun.
Yeah. Well,
So
fortunately, code is easier to change than hardware, generally speaking. But
usually, yeah. And maybe this only applies to a simple test and not necessarily to this run. You know, I don't know. But the idea would be to short the coil at the peak of the wave only for one short little second. And depending on if we short it on the positive or negative or positive, we can use that stored energy in the coil, and that might require an extra output. So like, let me give you a scenario. I'm running during the point when the coil is supposed to be on, right?
right.
I charge the coil really briefly. I disconnect the coil from the batteries. I wait a specific time, not degrees, but a time,
Yeah.
and then I short the coil into a cap and I capture that high voltage spike. And I only do it for the peak of the wave, so for as short as I possibly can, almost, because these relays are getting pretty close to their switching frequency at that point. And then the energy is now in the cap, isolated from the coil. Okay, the cap is going to be isolated differently than what we have it right now. So pretend like instead of shorting the coil to the cap, I'm going to take 2 relays and isolate the cap.
Okay.
And why I want to do that is because then when I connect, I want the ability to connect it up to the coil at a later time. Or I want to be able to connect it up to the batteries and flow that current backwards. And I can do all that. It gets a little complicated, but I'm just saying, like, I want the ability to adjust timing. And maybe that's a separate output. Maybe the short, like, it needs to be included somehow.
Well,
So it gets a little wonky here, but you see you understand the reason.
Yeah.
I want to short the cap against the coil at the peak of the wave so I can capture that,
right.
and I might want to fire it back into the coil again.
Well,
But the thing is if you keep it shorted, so like here's what I learned. If you short the cap against the coil and just keep it there,
yeah.
you have a humongous drag on the magnet. It creates a high resistance or a lower resistance, and I want to remove that by just capturing the peak of the wave.
Right. Well,
And
even at 1/4, my problem I'm having while you're talking here is even at 1/4 of the resonant frequency, that's over 1600 RPM.
Well, that's right. And so
there's no, I mean, we can't even make relays go that fast. That means relays have to be switching on and off in less than a millisecond. You know.
Well, it won't be doing it continuously, because like you just said, I don't know if that's possible.
I'm almost positive it's not possible with relays.
But you know how long it takes for the coil to receive a charge? Let's say it's, well,
Yeah.
the whole charge time is like, originally we thought 150. So let's say we only charge it 50 or less, 40,
Right.
30. That will be the whole on time. Then the short time will just be basically as fast as we can flick the relay to get it to short at the peak of the wave. So disconnect power, short at the peak of the wave. Because the thing is if it's the wrong polarity, we get the wrong reaction.
Right.
So it gets a little confusing. That's why we need to sit down and think about it.
Well, I'll try to think about it.
So you can go about this however you wish. You can go about it just generally speaking the way you already were, and don't really worry about this. Just include the timing for the short into the program.
Yeah.
And then if I say, well, let's remove the short from the timing, then can you just take that piece of code out and the rest of it keeps running and it just recalculates everything with that missing? Like, can you do that? And if you think ahead, then you can make it so it's easier to do that. But if you don't think ahead, then it's going to be a bear to go back and do.
Yeah.
So I'm trying to save you.
When you had it running the other day on the relay a couple days ago,
Yeah.
what RPM was it turning?
I was going real slow. It was like probably less than what I was spinning it right there.
But it was running by itself though, right? I mean, I saw the video. Yeah.
Yeah, it was running by itself, but
I know the timing wasn't optimal or anything.
yeah, it was out of whack. But these particular relays, my problem right now is I'm probably going to always have to stick with small relays to get the fast switch time. I can't put a big contactor in there, I don't think.
Right.
And I'm cool with that.
You got a lot of those relays, right?
Well, these are all the ones I have here in this particular style. However, I'm sure we can fix that by I looked out in my stuff and I have 110 volt DC relays, and I probably have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Probably have 50 of them on some boards out there I could desolder. But realistically, I would just order a huge amount of these small relays and make them do their job, because they seem to work really well. They switch super fast. They don't let the arc go. I mean, it really is a great control means for this high voltage stuff, because you can't do that with semiconductors. They just explode.
Yeah.
So I'll let you think about it, but I just wanted to make sure that you were understanding some of the conditions.
I think maybe we should start out with slow RPM, like 45 RPM or 60 RPM or something like that, and then work our way up after we get a better feel for everything.
Well, whatever it will run at, which means it has to run on its own, then we'll go with it, whatever that is.
Yeah, okay.
So if you want to just do simple tasks such as fire only the output and then make sure the encoder part works, like I can just test that piece of the program. Or if it's easier to do the degrees, just throw that together, like whatever you think. I don't know.
Yeah, well, it's probably going to take me at least a couple hours to get this figured out. I'm not going to have
sure.
it in 5 minutes here,
Well, I got to build these circuits. I got a week's worth of circuit building ahead of me.
It's not going to take me a week. I hope not anyway.
Oh, it's going to take me at least a couple of days. Because I'm going to make these relay driver boards. And I got to engineer the... Let's just put it this way. I got several days worth of work.
Okay. I'm not trying to push you. I'm just saying that I just got to have a little bit of time to do the code as well.
Absolutely. I wouldn't expect any other.
Okay.
It would take me months to figure this out. So
I love the way you made that thing so the falling edges are all the same and the rising ones are different. That is awesome. Yeah. I never would have thought of that. I would have just plastered holes in the thing.
Well, I had to make an index pulse, so I had to figure out a way to make it easy for you to never miss a pulse. It'll always be the same, but then also give you an index. So that was the way I decided to do it. So it should work well, I think.
What can I say? You're awesome.
We're awesome. Well, I wonder what the people on the interwebs are doing.
I don't know. I haven't been monitoring the chat.
Oh, they're all just doing. They must be sleeping. Shuba says blue is the new green.
I've noticed a lot of times they only come out in the afternoons and evenings.
Yeah. Well, Shubis is in Panama, so he's around. Okay, well, I am going to continue building these circuits for the relays.
Well, if you need me anything, just give me a shout out.
Yeah, I found 1, 2, 3, 4, 5, 6. I have 6 working photo couplers, photo transistors, whatever they are, with this circuit. They work with this circuit.
Wow, sweet.
Yeah, so and then I have all these fiber optic lines that are really big that will transmit that pretty well with these high power LEDs.
Cool.
So I think I'm gonna... Some of these cables I can take the shield off of, and then I can isolate the shielding, but because I think the shielding is gonna be like a big antenna. And if I don't connect the shielding to anything, maybe it won't matter. But I can cut the shielding off and it's just a big fiber line in there.
Yeah.
I don't know.
Well,
Because this one,
even if the shielding acted like intended, if it's an optical fiber in there, it's not going to pick up anything from it anyway. So,
yeah, but the point is to get as far as isolation as I can, and if it the
yeah, right,
if the RF is transmitting down the side of the fiber,
you
then
could,
that's not
like
helpful.
Tesla, shoot lightning bolts 30 feet and let it spark off the end of your finger.
Oh, well, we'll get there. This thing will probably do that quite nicely. Okay, well, I'll let you do what you need to, and I'll keep pressing
All right.
forward here. Let me know.
If I run into troubles or have questions, I'll buzz you.
Okay, I might. Should I write some information in that document?
If you want to, sure.
I mean, should I? Will it help you?
I was taking notes while we were talking. Maybe I'll put some stuff in there.
Okay. And then you can put the index pulse anywhere you like. By the way, so
What do you mean by that?
you could put the index pulse wherever you'd like, as in I can just adjust the index pulse to the motor, to the magnet. I mean,
Oh yeah.
right now we're at 45 degree before, but if that's a bit stupid, because we already discussed it's really hard to get the delay timing to work.
Right.
So if it's easier to put it somewhere else, we can put it wherever we want. We can put it at top dead center.
Yeah.
You know, we can put it wherever you want. So when you rethink about the programming,
Yeah. I kind of like I kind of like top dead center. That sounds good.
yeah, because don't forget, I do want to fire it before top dead center sometimes.
What do you want to call 0 degrees? Actually,
would it be better to just do 90?
yeah. Zero. On a circle? Where does 0 normally start at? On the x-axis at 90.
Well, like on a motor, like on an engine, I don't know where their timing sensor is. It's got to be before top dead center because they fire it before that. So my guess is that it's before that somewhere.
Yeah.
And we were doing 45 because realistically we'll probably never fire it before that.
Well, if
So we could do 90
Yeah.
if you wanted to.
90. Yeah.
I mean, that way you got time to process before you even get to the point where you're going to fire.
Yeah.
And that way it's not delayed by a whole half cycle. It's only delayed
By 90, you mean 3 o'clock?
Yeah. Well, it would be 9 o'clock. So it'd be 90
o'clock?
degrees before top dead center.
Okay.
Or you could call it after, whatever you want.
Well, if you put in at what degree you want it to fire, as long as I know where I'm starting, you know.
Well, I was just thinking, can you process in the first 15 degrees for that fire cycle? Because now you have a lot of pulses.
Yeah. Well,
depends on if you use.
If we have 12, we only have 2 pulses, but
Yeah.
I would think. I think we should put 0 degrees at top dead center, 12 noon, and then if you want to fire at 270 degrees, or you want to fire at 300 or 310 or whatever, then if I start counting degrees at 12 noon, you can just put in whatever degrees you want to.
Well, what if I want to fire at negative 15 degrees?
Well, that's not negative 15. That's 285 or something, you know, or 345.
Well, I want to keep it to 180
Oh, okay. All right.
because I'm only worried about every half cycle.
Right.
And if you give me 360, it's going to get harder.
Okay, I'll give you 180 then.
But if you give me 180 and I fire at top dead center, then you'll never be able to fire at negative 15.
Yeah.
So that's why
unless I allow you to put in negative numbers, but
I know, but that gets it doesn't get more complicated.
okay, it's 9 o'clock. Then make it start at 9 o'clock.
Yeah. So if the index pulse is is when the magnet is at 90 degrees, then that gives you a little bit of time to process where it's at. Now don't forget the other cycle. So like for instance, okay.
The other cycle would be minus 180 or plus 180. Yeah.
Yeah, it would be, yeah. And so the thing is though, is you should probably use the encoder pulse to determine that and not the previous half cycle, because that's where we were having problems last time.
Right, yeah.
Okay. All right. Because that thing will automatically be updating at all times, every single pulse, and that'll give us 12 more updates rather than the 2 that we were having.
Right, index. So you're gonna put index at 9 o'clock.
If the magnet is at 9 to 3, just like it is right now, if you can see it.
Yeah. Right.
Like this. Then that's when I'm going to fire the index pulse.
Right.
And then you'll have however much time. So
you know what you could do if you really wanted to be sneaky. I don't know how hard it would be for you to do it, but you could put an index pulse at 90. I mean, at 9 o'clock and 3 o'clock on your wheel.
Yeah, I can put 2 index pulses on there. Then you don't know where you're at, though, because see, the thing is that I don't want to get it at 180.
Yeah. Oh, yeah, we need to know the negative. Okay, yeah, never mind. I can figure it out in software. It's no big deal. Okay.
But, by the way, the reset button on the panel is not connected to the reset button on the Arduino, which means we can use it to flip our polarity.
Do you know what pin it's on?
I'll figure it out for you, but I'll put it in the sheet. I don't know yet because I got the wrong information because I thought we were using that other board, so I got to delete those schematics and put in the real ones.
Yeah, that was my bad. Sorry about that.
That's okay. I was confused. I was like, yeah, I got a graphical LCD. That's what you said.
Well, I do have a graphical one, but I grabbed the wrong one out of the box. I grabbed that silly character one.
Well, do you want to use the graphical because you got more space to write data? Because I'm pretty sure the pinouts are the same.
Yeah. Let me see if I can find my... I think I have a graphical one. I'm pretty sure I do. Let me see if I can find it, and if I can, I'll see if it's going to be hard to switch.
The only thing is if you use the graphical, it slows down the processor a little bit because it takes longer to process.
Yeah, that's true.
If that's a problem, we will just stick with what we got because I don't care. I was just asking questions.
Well, I don't have to be so verbose on the screen. I can make shorter text messages, you know.
Yeah, okay, alright. So we'll just leave it alone.
Alright, that sounds good. Alright, so for now we're going to start with the index at 9 o'clock, and then if we have to change it, we will.
Yeah, and I'll try to update that document right now.
Okay.
And
Sweet. This is going to be exciting. I'm looking forward to this.
Yeah, I'm looking forward to being able to control that short cycle, to be honest. That's the important one for me. I think that's an important piece of this.
Yeah, I just hope we can make these daggum relays in the microprocessor go fast enough to do what you want to do.
Well, if it's 118 hertz, what's a quarter of that? It'd be times 4. So that never changes, by the way. That pretty well always stays the same because the coil's resonating at its self-resonant frequency.
Right.
So therefore, whatever that time is, as long as I can flick a relay at that, I'm good. Everything else is probably slower than that, a lot slower than that.
Yeah.
Actually, everything will be a lot slower than that, except for the index pulse. But everything else, all the outputs are slower than that.
Yeah. Well, we should, we should be good.
I haven't put a short relay on here. My guess is the spark's going to jump the gap no matter what, fired or not. and so now I'm going to have to Either A,
Yeah.
get a bunch of relays, or B, I found my contactor box. I don't know how fast those switch, but they're pretty slow compared to these little guys.
Yeah, for sure.
All right.
Yeah, yeah. Put 152 relays in series to tame your spark.
Well, you know, to be honest, surprisingly, I was playing with this thing yesterday and that day before, and looking at there was 0 spark. And I've never gotten that yet. I've always had a spark because you're pulling contacts apart that are gonna spark.
Yeah.
So surprisingly, I would have never thought that the best means of controlling high voltage electronically is mechanically. Even at this speed, you can actually do it, and they all just fire at the same time. Like, it's kind of surprising to me. I would have never thought taming high voltage with banks of relays, you know, just didn't even dawn on me.
Yeah, that's cool.
So, all right then.
Alrighty then.
I will speak to you sooner than later, I think.
Yes, sir. I'm sure that's true.
All right, take your time.
Okay.
All right, I'll let you go.
Okay. Bye-bye.
Bye. All right, I am going to go to the bathroom. All right. Hi, Lily.
What's that for? I have to go on. I have to go under. I want to just try.
What's up, kid? I love you. What are you doing?
I'm going under.
I saw that.
I didn't do that.
I know. Good job.
That's good. Ooh. Oh. How was your? 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 How was your
Set them on the ground. Then you can sit, okay? Are you having a good day?
Mine's upstairs.
Yeah? Is that cool?
What's that baby tire?
That is my mechanical device.
Oh, that's cool. Ooh, I have to learn this. I just like it. So, I'll need to try it. So, I want to talk to Mommy. Daddy's different. Daddy's different.
Now where are you going? Bye.
This is going here.
Okay. See ya. My print actually looks really good. Printed pretty fast. Okay. I need to go find the other. Okay. Print screen. Okay. offset goes to pin 8. Of expansion 5.2. So that's analog 8. Okay. And then 7 and 1. No, 5 and 3. Go to that encoder. Let's see, 5, 3. Oh, A8 goes to D29. Oh, I'm so confused. Let's see, that's that one. Where's that one? That one. That one. That one. That one. D29. Okay. D5. Should be right. 5 times 2, that goes to A8. A8 goes to digital 29. Okay. Did my things crash again or something? Hello. Huh, that'll work. Okay, let's get figuring this stuff out. We're doing good. We're moving along. We are doing pretty good. guess I need to desolder these LEDs. And then I'm going to make this schematic. So I'm basically going to make a little box that I can pull all these off with. Still wonder why that one other one doesn't work. I somehow broke it. I don't think it's up here. Maybe I threw it down here. Oh, this one. Maybe I just shorted the wires or something. Oh. Now it's working. I bet I just shorted it out. Okay, good. That gives me a little bit better options. Let's see how well this works down one of these fibers. I think I already tested this, but let's test it again. Let's test it again. Oh, one is black. Yeah, that one's not very good. Wonder why it's so bad. Well, let's see if even the bad one works. I put that right on there. Nope, probably gotta be a good one. No problem. Actually, what? Wonder why. Wonder why that one's so bad. Is it got a kink in it somewhere? I guess it could have got a kink and broke the fibers, but the cable's not kinked at all. It's just very strange to me. Alright, the other ones that I really want to test are these. So there's two, and then I can use this one and this one. That gives me 4 standard type. Maybe that's all I'll mess with. I'll just do those 4, and if I want to add some, I'll build another one. Maybe I can actually buy the right parts at that time. Okay. Those two are LEDs. This one is the transceiver. Let's just try to get this one to work real quick. Alright, it's happy. So that's 4 regular ones. This one, I would like to verify works with the laser, because it's a bit of a different sensor. I guess it's got 4 sensors in there, I don't know. But red and ground. Well, it's still very active, so let's try a fiber line here. Got to be right on the eye to get a clean input, but yeah, it's alright. So since these are pretty close to the same, those 4 and these 2, I will design the apparatus around those. I think the other shielded cables are the better ones. These braided ones. See how long these are. Find out what length I got. That one's got a... This will be a good one because one side is just like broke off. Actually, oh yeah, these are the fiber ones though. They don't have a rubber shield around them. These have the rubber shield. These are short. Not a good idea to cut these cables up. I'd like to find some thick fiber optic cable. I guess I could use these shielded ones. They're all really long. I got 4 short ones. And then I got these really long ones. These all look really good though. I guess I can use those. Okay. Make sure I have no more opto sensors laying around my bench. Looks like we're good there. I have that one. See, I had a whole bunch of sensors from that old stuff. Wouldn't think they'd be in my connectors box. I don't think so. I'm gonna go look in one more place. So like those are 3 oh, I wonder if those are see, they're covered in a plastic that's probably only rated for that wavelength. That's part of the problem. So, see, this one doesn't work. Alright, that's the one that's all weird. I couldn't get it to work. Let's pull it off here anyway. See if I can get it to come on a different way. Because let's throw that one down there. I'd really like to get this one to work as well. It definitely does not work. Okay. Alright. Just gonna go look through a few of my other boxes and make sure I got all my little pieces out. I'll be back in a little bit. Hi, Peak Positive. I'll be back in a few minutes, man. Won't take me too long. Alright, I found a few more, and I found these things, which I remember seeing, but I don't know what they are. I'll try one in the circuit and see if it works. It might actually work. So I got a couple different ones. That one's probably not going to work. That one might work. These are infrared LEDs and sensors. It's like a bunch of random little oh, there's a laser diode too in here. All kinds of things in here. Let's try them all. Pretty sure these are, well, they might be receivers. Actually, they might be, these are infrared though. Pretty sure those are infrared LEDs. Oh, that might be one though. Might be a good one. Oh, boo. Stays on all the time. Negatory. Alright, these are both. I think this one will work actually. Can't tell unless I pull it out of there, I guess. It does not want to come out of there. Probably no good. These probably no good because these are also dark, probably infrared only. Okay, these, well, those look like driver LEDs, not inputs. Okay. Well, we did try, that's what matters most. I might have some more I want to go look here in a second. Okay, good try, good effort. I think I'm going to throw these in the LED box. I can just leave them in this bag. There's a laser diode there. There's a magnetic Hall sensor from one of my old projects. I will leave those in there. That can go in a different place. Okay, very good. So I still got the same four. I'm gonna go look in one more place, including in the top side of this. Don't think there's any in here. There's quite a few little things in here. Might be one floating in here. I don't think so. Neon relay, 12 volt, keep that one out. There's another one of those. I wonder if that's the, oh, that's 12 volt too. Omron. Okay, I'm going to go look in one more place. few more spots to look in. Oh yeah, I was going to try these. There's a small possibility that these are actually exactly what I want. Unless they're lasers. Unless I'm not sure about. Yeah, I think they're a laser or something. It could just be an early version LED, but they're like gold plated. Real weird. Got them in a box of old stuff. Okay, I have a few more places to look. I'll be back. Hello. What? Hello. Huh, they're both the same. Okay, that was probably better. What? Let's see. Out of this box, I need the screws, or the, somewhere in here there's some. There, that's what I want. Is there 4 of them in there? There's 4 of them in there. Cool. One set. This, I don't think I need no lenses. Oh, there's another cable in here. It's a short one, but well, it's got the ends broke off. Cool. There's one good end and one broken end. Maybe I'll cut that one. And this one's the same. So maybe what I'll do is I'll just use a short section as the isolation. I could sacrifice one of those. And then the bright LEDs, those parts. Kinda sucks I can't get the receivers to work, but I guess that's the way it is. Oh, that was really scratched up. I kind of wonder if I can break the glass bead out of there. Which one is this? This is the right side. I'll try it. I need 4 of those right now. Oh wow, that's like, oh, those are two transmitters. So that's 4. I'm gonna try to cut that one open. Because these just do not work. These small fiber optics just are not powerful enough. Try it again anyway. I guess maybe they could be if I make them more sensitive, but the problem with that is that might trigger statically, which I don't want either. The light comes through, but it's not bright enough to trigger the photo transistor, I guess, is the problem. Which makes sense. Alright, well, that's fine then. Let's just see if we can pop this one open real quick. I think what I'm actually going to do is just try to smash this and break the glass out of it.
Where's the next step?
Sure. Whew. That's code. There's like a glass bead on the end of this. And it is hard, apparently. Wow. Oh, it's cracking. Yay, it's cracking. That's what I want. Because if I can get it out of there, then I can get down to the transmitter without the glass. There we go. It's just an LED, but okay, now I got one without the lens. I am curious how bright it is without the lens. Because the lens is technically on there for protection more than anything. It's just a piece of glass. So I used a 500, or actually a 470 ohm. And the LED is, I'd suggest, plenty bright. I could go slightly lower. Go with a 330. Don't have any quarter watts though. I guess I'll stick with 470. Where's my crimps? Oh, where you at? Soldering iron's hot. Where's my crimps at? Oh, there's, I put them away. Good job, me. So depending on where I put these on, or put these out at, either way I'm gonna put crimp the ends on there, but put these up there so we don't lose any of them. Let's see how bright this cord is. So I'm going to use a 470. I used to fix amplifiers all the time. 470 resistors would always burn out. So funny. I'm gonna put one of these on the positive. Okay, and then this is actually going to get a crimped pin on both sides. So I'm most likely going to repin the Arduino and stick these in a different spot. That one. Alright, I'm gonna put a piece of heat shrink on this one also. Somewhere I have a lighter. I would like to light this and heat shrink it. I don't know where that's at. Let's just see what this looks like. So we'll switch these. It's going to be 13. And the ground is actually right next to it. How convenient. Wow, it's totally not as good as having that glass bead on there. I would expect it to be plenty bright still. Especially if you put a piece of fiber on there. Let's try one. Let's try this one. Let's see, I put that right on there. It's pretty bright. So I could drive this thing harder. The LED could be much brighter. But the beam is not focused at all. It focuses really well in that glass bead. Alright. So I guess I'll make up all of these. These are look brand spanking new. I don't think they are though. They might be, actually. Okay. Let's see, this one is a good one. So I will use, guess I'll use the good ones. I'm just going to make up the proper ends on all of them. And when I connect them, I guess I connect the shield to my box. I'm going to make a small little box. And then I'll know for sure that these things will be exactly the way I want them to be. Charlie didn't eat that pretzel, by the way. Thought he would have ate that pretzel by now, but he is apparently having some digestion problems. Okay, I'll be right there. Alright, I'm gonna go eat real quick. I'll come back and do all this proper. I guess what I should do is make the circuit board and then do this while the circuit boards are being made. So I think I will. I'm gonna go eat some lunch. I'm gonna come back and design the circuit boards, and then cool, that worked out pretty well. And then yeah, things and stuff. I'm gonna try gluing on 2 more of these fibers though before I go. Those short pieces are right there. Okay, there's that one. I'm gonna actually glue one more little section on here. And I'll have all the sections on that I have. And that should be about the same length as my other sensors. I don't really need this extra length, but kind of wanted it to be as far away as possible. Okay. Where's the end? It's a bit weak. But let's see what the laser looks like down it. That was pretty weak. Well, let's pull this one out real quick and see what it looks like. It doesn't look very good either. I'll pull this one back out real quick and look at it. It's a lot better. Maybe it's just the end of this cable. Let's just put it back together real quick and just see. If it will read in my device. Let's just see. Because it might. Well, we'll try it, and then if it don't work, I'll just cut that one off. Not really a proper way of splicing these fiber lines, obviously. But what are you gonna do? Okay, I'll be back. I need some lunch. Red socks. I'm actually wearing. I am wearing red socks. I thought I was wearing a different pair. I'm gonna stop the stream.